Hey everybody, it's Miss Moran, and I'm here to talk to you about our newest unit of study, decimals. Decimals is one of my favorite units because it's neat to see kids take something that is so much related to fractions and just extend their understanding of stuff they've already done, because most students don't recognize decimals as being an extension of fractions, but it really is. So we're going to start off with an understanding that decimals really are just fractions. They're just written differently, and they're fractions that have special denominators of tenths and hundredths. Also thousands and 10,000s and 100,000s, but for our purposes in fourth grade, we're going to stick to tenths and hundredths. So when we worked with fractions, we had denominators of 2s and 3s and 4s and 5s and 8s and 10s and 12s. But for decimals, we're only going to work with tenths and hundredths. So one thing we're going to connect this to is not only fractions, but also to place value. So we're used to knowing about ones, tens, and hundreds, and so on. It's important for students to understand that this is my ones place, this is my tenths, and this is my hundredths, and that there is actually an end to this number, and this end has a decimal point. Even if they never knew it was there, it does exist. And so this is where your whole numbers lie, and on the other side of this decimal is where your parts lie, or your fractions. Okay, these are also our decimals, and we're going to learn two new places. One of those is the tenths place, which is what you get when you take your whole and you split it into 10 pieces. And the next one is when you would take a tenths and you split that into 10 pieces, you would end up with hundredths pieces. So we have two new places, tenths and hundredths. And we're going to start everything that we do connecting it to fractions first. So we want to have an understanding of the fractions, and it makes the decimals a whole lot easier. We used to teach decimals as an extension of whole number place value, and students didn't really have that conceptual understanding of it being part. So we're going to look over here at some examples. So here's the first example. We're looking at a whole, one whole square, and it's broken into 10 pieces. So I have the fraction 7/10 here, and so I'm going to write that just as I did with fractions. Denominator's 10, there's 10 parts to the whole, and I'm going to shade in 7 of them. Okay, so how we're going to write that is we're going to say decimal separates my wholes from my parts. I have no whole squares filled in, and I have 7 tenths. So I'm going to put that 7 and I'm going to put it in the tenths place. Now, one thing students have to understand is that even though it's not written, it has a denominator. It's an understood denominator of tenths just by putting it in the tenths place. Just like if I have a number like 458, if I ask students what that 5 stands for, they know the 5 doesn't mean 5, they know it means 50. And I say, well, how do we know it's 50? I just know that's the tens place, and 5 in the tens place is 50. 4 in the hundreds place is 400, I just know it. Well, now we're just going to know something else. We're going to know that anytime we have a number in this first place behind the decimal point, that it's an understood denominator of tenths. So we kind of call them lazy fractions sometimes, because it's like writing the numerator only. All right, here's another example. This is 10 tenths. All right, well, 10 tenths is going to fill the whole, and this is a concept we've already worked with. We know that anytime we have the denominator and numerator the same, that shows the whole. So 10 tenths is equal to 1 whole. All right, well, how are we going to write that with a decimal? Well, this is my tenths place. We can't cram a 10 into one single place. It's a 2-digit number I'm trying to put in a 1-digit spot. So what has to happen is it has to overflow to the next spot, just like we do with whole numbers when numbers don't fit into one place. So this is 10 tenths, which is also 1 whole, and 0 extra tenths. It still looks kind of like a 10, but it also shows 1 whole and 0 extra tenths. All right, and then we'll have another example here. This is for 2 and 3 tenths. So students get a little confused here because there's a missing word here that students have to read into. They have to know this "and" is what separates a whole number from a fraction. So we're going to write this as a mixed number, just like we did with our fraction chapter. This 2 has an understanding of being whole. So it's really 2 wholes and 3 tenths. Okay, so I'm going to shade in my, I'll go kind of quickly here, my 2 whole squares, and then in this one, it's broken into 10 parts, and I need 3 of them. Okay, so how are we going to write that? Here's my decimal. This is my ones place over here, so I have 2 wholes. This is my tenths place, and then I have 3 extra tenths. Okay, the denominator is understood because I put it in the tenths place. It's written here, it's understood over here. All right, so we're going to say if we take a tenth and we wanted to further split that into even smaller pieces, we would be only able to split it into denominators of 10, hundredths, thousands, and so on. So our next one we're going to look at is fractions and decimals in hundredths. So I've taken my 10 columns and now I've split them 10 times this way to give me 100 parts. So my denominator becomes 100. And this time I want 64 hundredths. So I'm going to write my fraction just like I did in my last chapter. That's easy. And I'm going to fill in. Now I don't have to count these all at one at a time. You know these are in columns of 10. So I'm going to fill in 60 and then 4 more. Okay, how do I write that? How many holes do I have? I have no holes, and then I have 64 hundredths. Hundredths is going to take up our second place value behind the decimal here. But I can't cram 64 into this one place. It's going to have to overflow. So it becomes 64, and I read this as 64 hundredths altogether. Now this is 64 hundredths total little tiny squares, but it's also 6 tenths. Here's 1, 2, 3, 4, 5, 6 tenths. And then here's my 4 little hundredths, 1, 2, 3, 4. So with place value, I can see it's 6 tenths and 4 hundredths, or collectively is 64 hundredths. Now, one of the biggest things we have to get kids to break away from is a habit that parents show them, and that's kind of a lazy way to read these fractions. Most adults would look at this and just say 0.64 or 0.64. And the danger in that is that students don't think about that this is actually a denominator. They think about it as a whole number, 64, when you say it that way. But it really needs to be read 64 hundredths. And if we start having them practice reading it that way, connecting it to the fact that it's the same thing as a fraction, it makes a whole lot more sense. So if I go back over here, parents, please don't read this as 0.7. Don't read this as 2.3 because that doesn't carry the correct meaning that we want them to have. We want them to know that these are based on denominators. They're understood denominators. All right, 8 hundredths. 8 hundredths as a fraction means I need only 8 tiny little pieces here. 8 little hundredths. Okay, so how do we write that as a decimal? These are the ones that throw kids off. I have 0 holes, and a lot of kids will see an 8 there and they just want to throw an 8 over here. But if they just put an 8 here, then they're changing this decimal into something different than it was here. This shows 8 hundredths. If I put it here, then it's going to be 8 tenths. But I have 8 in the hundredths needs to come over here. All right, now how many tenths did I have? How many whole columns of tenths did I have? I had none. So I see I have no holes, no tenths, and 8 little hundredths, or collectively I have 8 hundredths. Again, not 0.08. We don't want to get in the habit of that, or not 0.08. We don't want to say something like that. We want to use a good vocabulary of showing hundredths in words, hundredths with the denominator, and this is an understood denominator taking up 2 places here. All right, and then we have another one that has a mixed number. So this is 1 and 17 hundredths. So 1 and 17 hundredths. That's a mixed number. If I want to write that, I want to be very careful. I'm looking at 17 and not 7 or 70. So I'm going to fill in a 1 whole grid. And then 17, I can count 1 at a time, or I can say I'm going to do 10 and 7 more. Okay, and that's going to be equal to how many holes I have? 1 hole. And I need 2 place values for hundredths. I have 17 total hundredths. So 17 total hundredths collectively, or 1/10 and 7 hundredths. And we're going to learn that we can do this in expanded form as well. So just like we broke up whole numbers, we can break up these values and say, what does this 1 mean? That 1 means 1 whole. What does this 1 mean? Because that 1 doesn't mean 1 like it meant here. This 1 means 1/10. And what does this 7 mean? It doesn't mean 7. It means 7 hundredths. So we have an expanded form here, and that's something we'll be doing as we get into sometimes these larger ones that have mixed numbers. Sometimes we'll do that over here too. We'd say this is 6 tenths plus 4 hundredths, not just 4 tenths. All right, so that's an introduction to fractions and decimals and tenths and hundredths. We're going to do one more skill this week, and that is equivalent decimals. Equivalent decimals can be made very simply to understand if we understand them based like they did with equivalent fractions. So we're going to start with 4/10. I'm going to go over here, 4/10 as a fraction. Okay, now if I wanted to make that equivalent to something in hundredths, okay, again, nothing new. This is equivalent fractions from 4 chapters ago. If I'm going to look to make equivalent fractions, I'm going to say, how did I change tenths into hundredths? I did 10 times as many pieces. So 10 times as many pieces and 10 times as many to count. Whoops, sorry. It's going to give me 40 hundredths. So if down here it looks exactly the same here, doing one full column, but each one of these columns has 10 times as many pieces in it. So as a fraction, 4/10 is the same as 40 hundredths. As a decimal, 4/10 is also equivalent to 40 hundredths. Now this is sometimes hard for kids to understand because they don't think that 4 should be equal to 40, okay? In terms of the math they've always done, 4 has never been equal to 40, and 4 is not equal to 40, but this is a denominator. This 4 doesn't mean 4, it means 4/10. And this 4 doesn't mean, well, it means 40 hundredths, 40 little tiny hundredths. So if you look at place value, I have the same value here in the wholes, I have the same value in the tenths place, and I have no value here and a written 0 here, which is really the same value. So we would say that 4/10 is equivalent to 40 hundredths. Now if you just said 0.4 is equal to 0.40, kids won't understand that. So it's important to make sure we're understanding that vocabulary and using those denominators. All right, this is a similar version. This is a backwards model. So I want 50 hundredths. 50 hundredths. We learned about doing simplest form with fractions. Well, you can do simplest form with decimals as well. So 50 hundredths can also be the same as something in tenths. So how many full rows do I have here? 1, 2, 3, 4, 5 columns. Sorry, I should have said columns. So 50 hundredths. To make simpler form, remember we divide. It's not simplest, but it's a simpler form. We're going to divide each of those by 10 and get 5/10. And so as a decimal, 50 hundredths is equivalent to 5/10. This is a simpler version. So this is a less simple version. This is a simpler version. Okay, they both have 0 in the wholes, 5 in the tenths, and nothing written or nothing at all here has the same value. Okay, one thing we don't want kids to do is we don't want them to say that 5/10 or that 50 hundredths is equal to 500. So those aren't the same. So we've got different values in different places. We don't want to do that. So we want to make sure that those values stay consistent. All right, here's another one. This is 35, whoops, need a paperweight, sorry. This is 35 hundredths, and we want to make that equivalent to something in tenths. Okay, it's not going to work here. So can I turn hundredths into tenths? Yes, by dividing by 10, but I can't do 35 divided by 10. That's going to give me a remainder. So it's impossible to take something that is in hundredths that has a value here other than 0 and to make it be something in tenths. So in order to have equivalent decimals, you're going to have those multiples of tens. Your 10s, your 20s, 30s, 40s, 50s. 35 is not going to work. So we're not going to be able to make something into tenths with 35 hundredths. That won't work. I can make it into 3/10, but then I'd have 5 little extra hundredths here, which doesn't make it equivalent. All right, so we're going to take that understanding and also look at how we can represent this as parts of a dollar. So where this was our wholes and this was our parts, this is going to become our dollars and this is going to become our cents. Our cents can be out of 100 to make a dollar. So we're really going to think about this as being 1/10 of a dollar, that's our dimes place, and 1/100th of a dollar, that's our pennies place. So we're going to be working with money amounts, not using just a cent sign. We kind of think of that as being kind of immature, kind of a 2nd or 3rd grade thing. We're going to use a dollar sign here, and we would read something such as $4 and 32 cents. All right, so a quarter. A quarter is 25 hundredths of a dollar. So how we would write that is $0.25. So I'm connecting my hundredths denominator here to my 2 places here, which is hundredths. Nickel is only 5 cents out of 100. This is one kids have to be really careful on. They'll see a 5 and want to just throw a 5 here, but it's 5 hundredths. Hundredths needs 2 places, has to come over here. These are the most missed decimal questions, these hundredths, these single digits hundredths. Students want to mess those up sometimes, so we've got to be really careful about those. The dime is 1/10 of a dollar. We'll put a 1 in the tenths place, but that doesn't really look like money. Money is always out of 100, so we want to make an equivalent decimal to hundredths and say that a dime is 1/10 of a dollar, but it's also 10 cents out of 100. So there's our equivalent decimals coming in. Okay, the penny is only 1/100th of a dollar, so that's going to be $0, only 1 cent. Got to put that 0 in there. No tenths and only 1 cent. A half dollar is worth 50 cents out of a dollar. That's 50 hundredths, 50 cents. And a dollar is 100 cents, which is also 1 whole. We're going to write that as $1.00. And then some random ones here. Instead of using this cent sign, is 47 cents. That's going to be $0.47 because it's 47 out of 100. 6 cents is going to be 6 out of 100 cents in a dollar. Make sure we get that 0.06, sorry. And this is why we don't use dollars in this random cent sign, because it's hard to say $1 and 32 cents. It's much easier using dollar sign, $1 and 32 cents, using decimals. It makes it a whole lot easier to add, adding easier on calculators and cash registers, lining numbers up, all of that stuff. All right, thank you so much for watching. I know that's kind of a long introduction into decimals, but it's really important to lay this foundation early. We'll have a couple more decimal lessons that are going to come out on a video next week. So thank you so much for watching. Go ahead and like or comment. I appreciate it. Bye-bye.